Hello and welcome to another video. In this one I'm going to explain how to work with polynomials. So if you have to expand something like this, like two polynomials multiplying each other, you take the first thing and multiply it times the other three individually. The results of what you're going to get, you're going to add them. And I'm going to explain how that is done in a minute. But think about it, you're going to take all of them. That includes the 4. So it's going to have minus 4 times 2x cubed, minus 4 times minus 4x, minus 4 times minus 5. Let's actually go ahead and do these multiplications. Now follow me in your head. So this times this is going to give me 2x to the power of 5. And now the next one. The next one's going to be this thing times this thing. So you're going to get minus 4x cubed. And now minus 5x squared. And I just carry on doing this. Now keep in mind that how the signs get arranged, right? Because for example, x times 4x gets minus 4x squared. And that's very important to not mess up the signs. And you finally end up with minus 8x cubed plus 16x. Now realize that the minus and the minus cancel each other, and plus 20. Now you're going to be able to group some of these. To the power of 5, there's only one thing. It's only the 2x to the power of 5. To the power of 4, there's only one thing, but to the power of 3, there's 2. And when you add them together, minus 4x cubed minus 8x cubed gives you minus 12. Same thing happens with the x squared. Same thing happens with the x to the power of 1. And the 20 just stays there alone. So that's how you expand a polynomial. Let's now look at factorizing a polynomial. We're doing some quick revision here of how to the algebra of polynomials. Now I can take an x out. Why? Because I can write it like this. This is a consequence of what we just did. Because x times x cubed, x to the power of 4 is going to give you x to the power of 5, and so on. Now the best way to do this, the better way to do this is to take out x squared. Because you see, you can also do it this way. It doesn't mean that one is wrong and the other one's right. It just means that one is going to turn out to be more useful, which is this one here. So always tempt for that one. And finally, if I know that I have a factor of a polynomial, look at this one here, right? X plus 1 being a factor of x to the power of 3 minus 2x squared minus 5x minus 2. It means that x plus 1 times something is going to give me that thing there. That's what factor means, you know, like the same way that 4 is a factor of 25. You know, it means that 4 times 6 is going to be 25. 4 times something is going to give me, 24. Now, that something is going to have an x to the power of 2. And it's going to have an x to the power of 1. Which is why I can assume that, well, x plus 1 times something is going to give me this x to the power of 3 minus 2x squared minus 5x minus 2. So if I multiply this thing using my old, the thing that I did earlier on, this is what I'm going to be getting. I'm going to be getting ax to the power of 3 plus bx squared plus cx plus ax squared plus bx plus c. I'm just doing one times the other and so forth. Now I can group them now and say, well, the x cubed is going to be a, but the x squared is going to be b plus a x squared, and the x to the power of 1 is going to be b plus c times x, all of it plus c. And now I can just check and say, well, a is going to be 1, right? I can compare this result with the polynomial that I have to get, which is x cubed minus 2x squared minus 5x minus 2. And I compare, and so a must be equal to 1. B plus a must be equal to minus 2, b plus c must be equal to minus 5, and c must be equal to minus 2. Hence, b plus a equal to minus 2 must be then that b plus 1 is equal to minus 2, hence b is equal to minus 3. C, on the other hand, let me just write this one as they come around. I'm going to get x to the power of 2, because a is 1, minus 3x, because b is minus 3. And c, I can just see it straight away. It's going to be minus 2.